Rational functions are one of the most basic yet useful tools for any mathematician. Formally defined as algebraic fractions such that the both numerator and the denominator are polynomials. They are really important as they supply important examples and occur naturally in many contexts. The very basic rational function looks like this. To cover the concept in its entirety, we will be going through the details of three things: domain, codomain, and asymptote, and then graph these on TI. So the first one is asymptote. An asymptote of a curve is a line such that the distance between the curve and the line approaches to zero as one or both of the x or y coordinates tend to infinity, but the curve and the asymptote never intersect. The second one is domain. It is the set of input values for which the function is defined. Then we have the codomain. The codomain of a function is a set of its possible outputs. So basically it consists of all the values of y which are there for any function. Now with the very basic knowledge of these three things, let's move on to the graphing part and do some hands-on with TI. Here is the graphing section of TI with the graph of a rational function plotted, and the function is fx is equal to 1 divided by x plus 2. For now, let's learn how to find the asymptotes with the graph of this very basic rational function. It is clearly visible how here this portion of the graph is approaching to x minus 2. Even the point values for this function present in the table shows how the value of x is equal to minus 2 gives the y value as undefined, and hence the graph never touches x is equal to minus 2 and it's an asymptote. This one was in vertical asymptote. Whenever there is a vertical asymptote in the table, the x value of that particular asymptote will give the y value for it as undefined, denoting that the vertical asymptote is present over there. There's also a horizontal asymptote here. In this portion of the graph, it is visible how the curve approaches to y is equal to 0. With the increasing value of x in the table, the value of y approaches to 0. Again, it shows how there is a horizontal asymptote, which is y is equal to 0. Therefore, whenever there is a horizontal asymptote in the table, the y value will go closer to 0 in this case and any another number in other case. Now there is a different function plotted on the graph, which is y is equal to minus 4x divided by 2x square minus 9, which is definitely more complex than the previous one. So this time let's set the domain for this function, and for that first press tab and get on to the function. Now to set the domain, press Ctrl plus and then select the bottom rightmost option to separate the domain and the function. Then put the required domain like this. Okay, so we have set the domain, which is x is greater than equal to minus 6 and smaller than equal to 6. Now let's move on to the next function and look at the codomain. We'll use this function with the specific codomain. The function is y is equal to 6x square divided by 3x square plus 14 minus 3. To find the codomain, first find any horizontal asymptote present over here. The horizontal asymptote for this function is y is equal to minus 1. But for the codomain, two ends are required, and hence the local minima for this graph is also needed, which is y is equal to minus 3. So in the table you can see how it's y is equal to minus 3, and even from the graph you can see that. It is pretty visible that the entire graph lies between the asymptote y is equal to -1 and the minimum point y is equal to -3. To verify or to even find the codomain, the table can also be used. As at x equal to 0, the y is -3, which is the least value of y in the entire table for this function, and hence it is the minimum point. And as the value of y increases or maybe decreases, it approaches to y is equal to -1, but it will never exactly reach y is equal to -1, and hence it's an asymptote. So again, the codomain found for this function is y greater than equal to -3 and less than -1. So now we know what domain, range and asymptote are and how to apply them graphically.